Everyone, Patrick CK here. If you've been following the series on the Ender 3 V3 SE, you know we've already made big changes. In the last video, we moved the spool holder from the top of the printer to the side to lower the center of gravity and minimize that horrible spool wobbling. And it worked out great. But that unsupported tall gantry still had me concerned. The V3 SE and KE are fast. As we crank up those speed settings, that tall Z-axis gantry acts like a swaying mast. To test this, I designed a custom Z-axis stress test using an intricate honeycomb tube based on this ring model from Lauren's VDV. I chose this over simple cylinders because these sharp corners and rapid direction changes trigger the frame's tendency to vibrate. At 220 millimeters per second, physics took over, and you can see the movement, especially when I put the spool back on top for the initial round of testing. That spool is dancing all over the place. We can see the impact of that on the model at the top, where we have some wavy and out of place layers. With the spool back on the side, it's better, but at the top we can still see some wavy layers. Just pushing on the frame at the top shows how much flex there is, even after making sure all the screws around the gantry are properly tightened. To fix this, we're installing the YOOPAI Support Rod Kit designed specifically for the Ender 3 V3 SE and KE. This system uses dual support rods to brace the gantry from the back, creating a rigid support structure that should keep the frame more stable at high speeds and improve the quality of tall prints at any speed. I want to thank my viewers who recommended this kit. Taking a look at what's in the box, the build quality actually surprised me. After the instruction manual, we're getting a thick, heavy-duty steel brace for the bottom that has absolutely zero flex. Next, we have all the screws with spares, the Allen keys for assembly, and a small wrench. Then you have two more thick steel plates for the top of the gantry. Most importantly, the rods themselves. These are made from aluminum, but they feel premium. They're lightweight but rigid, and they match the look of the V3 series perfectly. The installation starts at the top of the gantry. You'll need to replace the 6 original screws that hold the gantry down. The kit replaces these with longer M3 by 25 millimeter screws to accommodate the thickness of the new steel plates. We'll do one side at a time. The original screws need the 2.5 millimeter Allen key, while the new ones require the 2 millimeter key. Next, we move to the back of the printer down at the base. You'll need to replace the silver drive rod screws with the longer M3 by 16 millimeter screws. These will hold a new bottom bracket in place. Just make sure to orient the bracket so that this hump is on top and the wings are pointed forward, because it will screw in other orientations as well. Once the brackets are in place, you can assemble the rods. Each end of the rods will get an eye bolt and a nut. Don't screw them down all the way, since we'll adjust the length in a later step. Now, here is a crucial tip from my experience to save some frustration. The pre-drilled holes in both the top and bottom brackets are incredibly tight. I highly recommend pre-driving the M5 by 12 millimeter screws into the rod holes by themselves first. This essentially cleans the threads, making the final assembly much less of a headache. Now connect the rods by passing those M5 screws through the eye bolts. I found it easier to attach them to the top brackets first. Once those are in, you may notice that the eye bolts at the other end of the rods don't quite line up with the bottom bracket. This is okay. To make it line up, you simply spin the rod itself or the eye bolt or both to extend or retract the length until the eye bolt lines up with the brackets. Once they're in, snug everything down and use the included wrench to tighten the nuts. Make sure to put all your original hardware into the now empty Ziploc bag in case you need them in the future. Because this kit installs on the back side of the frame, the front of the printer stays clean and open. Pushing on the frame now, there's still a little give, but definitely not like before. It feels quite a bit more solid. With that, let's print another stress test with the support rods in place and the spool on top. The spool is still wobbling some, but I don't know if it's just me, but it feels like it's wobbling a little less than before. But we'll see once the print is done. And the biggest improvement is on the cylinders at the top again, which look less wavy than the first test. Now we have to talk about the problem. My original side-mounted spool holder mod sat exactly where these new support rods now live. So we need to modify our mod. Beyond this clearance issue, version 1 had a hook that went around one of the rubber feet underneath the printer. I heard from a couple of you that this part of the mod was either too short, leaving the mod dangling, or too tall, lifting the printer off the table. The only reason I can think for this happening is that the rubber feet on the bottom are inconsistent between printers. I took this feedback into account when thinking about the next iteration. For the new SR version, SR for support rod, I went back to the drawing board and I thought I could turn the support rod from an obstacle into an advantage. This new design actually snaps directly onto the support rod itself, providing an anchor to keep the mod from tilting forward. I also added an extension that fits into the cavity created by the new YOOPAI bottom brace. This creates another anchor that prevents the weight of a full 1 kilogram spool from twisting or sagging the holder. When installing it, you will need to apply some force to seat it down all the way. It's a tight fit, but once it's in, it feels incredibly rigid. No bending or twisting out of place. And now you can actually pick up and move the entire printer without worrying about the mod falling away like with version 1. It's a much more solid anchor point that doesn't care about the height of your printer's rubber feet. It takes about 1.5 hours to print and requires no supports since it prints on its side. Lastly, I also had to rethink the filament guide since we added those new plates on top. Luckily, they have this open edge we can utilize. I redesigned the guide to hook right onto them. And because I can't resist a good excuse to use magnets, those steel plates allowed me to add a 40mm bar magnet for extra security. It's not strictly necessary, but it makes the fit feel very deliberate. I've included 2 versions of the guide like before, a roller version and a simple loop version. Both are quick 15-minute prints with no supports needed. You can find all the files on both Thingiverse and printables at the links in the description. I ran the stress test model again. The final results are great. No wavy lines, no more swaying, just a smooth, stable flow, even at the very top of the Z height. Just like with version 1, I think one of the biggest benefits is having that little bit of slack in the filament so that it's not constantly tugging on the spool, causing it to wobble around. Is it perfect? No. The spool isn't completely isolated from the printer, so it still vibrates a little, but it's not constantly jumping and wobbling around like before. Of course, I'll keep working on improvements over time. If you guys have ideas, feel free to let me know or spin up a variant of your own. Obviously, the only downside to this version is that you will have to have the YOOPAI Support Rod Kit installed to make it work, but I think it's worth it. Nevertheless, this is exactly why I love 3D printing. It's about solving these interesting engineering puzzles to make a good machine even better. I'm really happy with how this setup turned out. If you want to try this out for yourself, I've put a link to the YOOPAI kit in the description. And again, you can find links to all of the STL files on Thingiverse or printables in the description. In the next video, we're going to install the Creality Filament runout sensor and see if we can make it play nice with the new support rods and the side-mounted spool holder mod all at the same time. You won't want to miss that one. Until next time, this has been Patrick CK. Goodbye.